Leo, the personal care robot. UV Cup, the world's fastest camera. And finally, autonomous Roboat navigates the canals of Amsterdam. Stick around to find out more in this episode of News Bytes. Hello and welcome to Advanced Ingenuity Labs, your insight into technology. I'm your host, Aisha Sharif, and this is News Bytes, where we cover innovative developments in the latest technologies. As robots are becoming more and more accepted in our work environments, it won't be long before we see them not only as smart, strong mechanical machines, but also as caregivers. Robots are currently being used in healthcare settings to assist frontline workers and patients with daily tasks. F&P Robotics build robots that serve and assist people to improve their quality of life. Their personal assistant robot, Leo, is assisting healthcare professionals across Europe. Leo is a mobile robot with a multifunctional arm designed for human-robot interaction and personal care assistant duties. The robot is currently deployed in several healthcare facilities, autonomously assisting staff and patients with daily tasks. The friendly appearance of Leo has been well received by both healthcare staff and patients. According to F&P Robotics research, elderly people and healthcare staff quickly accepted the robot and were even polite to Leo. One elderly person described the robot as a play companion, and he regularly engages in games with Leo. According to F&P Robotics, Leo has 4 embedded computing units: an Intel NUC, NVIDIA Jetson AGX Xavier, a Raspberry Pi, and an embedded PC with an Atom processor. Each of the computing units is responsible for running separate modules with constant communication using an internal secure Ethernet network. Communication is based on ROS topics, which provides provisioning for additional modules to be integrated into the system if needed using standard ROS communication protocols. The robot's fully autonomous operation is made possible with the use of a decision engine, allowing it to make intelligent decisions regarding autonomous navigation, when to perform specific tasks, when to recharge, etc. In order to safely understand its environment and navigate around it, Leo utilizes a combination of visual, audible, laser, and mechanical sensors. The ROS-enabled setup allows researchers to access raw sensor data and have direct control of the robot. To protect the user's personal information, Leo utilizes onboard artificial intelligence and deep learning-based solutions so that there is no need to send sensitive data to cloud services. The gripper fingers are easily interchangeable. 4 digital inputs and 4 digital outputs, together with 2 24-volt DC power outputs, are available for the sensors. Furthermore, there is an interchangeable camera module attached below the gripper fingers. The camera provides a video feed of 30 frames per second. Also, force-sensitive resistor sensors are placed just below the artificial leather to detect physical presses on the head of the robot. As we've all had to adapt during the COVID-19 pandemic, engineers quickly made changes to Leo, enabling the robot to perform additional functions like disinfection and remote body temperature detection. A custom UVC light holder was designed for Leo, allowing it to carry the light on its back. Leo was adapted to carry out disinfection using an approved UVC light capable of effectively killing exposed germs, bacteria, and viruses on surfaces such as door handles, light switches, elevator buttons, and handrails. The world's fastest UV camera is capable of capturing ultra-fast events that last just a picosecond and is quick enough to see UV photons fly through the air in real time. The ultraviolet compressed ultrafast photography camera, known as the UV cup, is the result of an international team of researchers at Canada's National Institute of Scientific Research. UV cup is an emerging imaging technique that has been used to capture ultrafast events at speeds measured in trillions of frames a second, but has so far been limited to visible and near-infrared wavelengths. According to the National Institute of Scientific Research, compressed ultrafast photography captures the entire process in real time with unparalleled resolution in just one click. This spatial and temporal information is first compressed into an image and then, using a reconstruction algorithm, converted into a video. The team first had to develop a special photocathode and integrate it into what is known as a streak camera, which is a device developed specifically to measure ultra-fast optical phenomena. The team also needed to develop a new algorithm to take the data and construct an image out of it. The new system features patterned photocathode, which is used to simultaneously detect and encode blacklight. Jinyang Liang, who led the study, said, "Like a standard camera, our technology is passive. It does not produce light, it receives it. Therefore, our photocathode had to be sensitive to the photons emitted as UV light. This design makes our technique a standalone system that can be easily integrated into various experimental platforms. Taking the picture is only the first half of the job. It also has to be reconstructed. Rather than solve the reconstruction problem as a lump, the algorithm divides the reconstruction into smaller problems that it tackles individually. It's like trying to eat a cake. Instead of finishing it in one mouthful, you enjoy it much more, one small bite at a time." According to their research paper, to reconstruct the images, the researchers developed a new algorithm that is more efficient than standard algorithms, and its strength comes from dividing the tasks. With the advancements in both hardware and software, UV cup has an imaging speed of 0.5 trillion frames per second. It produces videos with 1,500 frames in large format. And as a light-speed imager, UV cup sees flying UV photons in real time. Even though it is the fastest camera in the world, the device can still be improved. For example, the chosen photocathodes have limited efficiency, so researchers want to explore other types of materials. Regarding reconstruction, Liang says that the algorithm has greatly improved the quality, but that it still takes quite a long time. To increase its speed, he's collaborating with another professor on using artificial intelligence to help improve it. The successful international collaboration and development of the UV cup will be sent to a research facility in France to visualize physical phenomena. It will be used to capture laser plasma generation, a phenomenon that is essential for deducing certain properties of materials, and UV fluorescence, which is important in medical imaging to identify biomarkers linked to diseases. If you enjoy this video and find value in our content, you can help us by sharing it with others. Also, leave a comment as we want to hear from you, and consider liking the video and subscribing to our channel. You may also click the notification bell if you don't want to miss our upcoming videos. To stay informed about our upcoming training courses and camps here at Advanced Ingenuity Labs, visit our website at advancedingenuitylabs.com and sign up for our email notifications. Let's end this episode with autonomous boats. The need to deliver goods, services, and passengers have been the motivation during the last 5 years for MIT's Computer Science and Artificial Intelligence Laboratory, CSAIL, and the Sensible City Lab. The researchers have been developing the world's first fleet of autonomous boats for the city of Amsterdam in the Netherlands, and have recently added a new, larger vessel to the group, Roboat 2. Self-driving boats have been transporting small items for years, but due to the small size of the vessels, they have yet to transport human passengers. The new robotic boat is 2 meters long, weighs more than 50 kilograms, and is capable of carrying passengers. MIT professor Daniela Russ, a senior author on a new paper about Roboat, and the director of CSAIL, said, Roboat 2 navigates autonomously using algorithms similar to those used by self-driving cars, but now adapted for water. We're developing fleets of rowboats that can deliver people and goods and connect with other rowboats to form a range of autonomous platforms to enable water activities. Working with the Amsterdam Institute for Advanced Metropolitan Solutions, the team created navigation and control algorithms to update the communication and collaboration among the boats. Aided by powerful algorithms, Roboat 2 was able to autonomously navigate the canals of Amsterdam for 3 hours while collecting data and return back to its starting location with an error margin of only 17 centimeters. One of the main goals of the project is to enable self-assembly with the intent of assembling into connected multi-unit trains. But controlling this movement on the water has been challenging. The system uses a distributed controller, which is a collection of sensors, controllers, and associated computers distributed throughout the system. There's no direct communication among the connected robots, and only one leading robot knows the destination. This leading robot first initiates movement to the destination. Then the other robots, as followers, estimate the intention of the leader and align their movements with the leader accordingly. The team tested their control method on 2 scenarios, one where 3 robots are connected in series and another where 3 robots are connected in parallel. The results showed that the coordinated group was able to track various trajectories and orientations in both configurations, and that the magnitudes of the followers' forces positively contributed to the group, indicating that the follower robots helped the leader. According to their paper, the simultaneous localization and mapping, SLAM, algorithm provides a higher localization accuracy for Roboat and allows for online mapping during navigation, which they didn't have in previous iterations. Next, the researchers are planning to build a 4 to 6 passenger version and apply active object detection and identification in order to develop more efficient planning algorithms, enabling the vessel to handle more complicated scenarios. That's it for this episode of News Bytes. As always, if you enjoyed this video and want more, leave me a comment and consider liking and subscribing. See you next time.